What's up, everybody? Happy Friday. I wanted to do a stream. It's been a little bit. I was trying to stream other things besides programming. I don't think it went all that well. So getting back to the roots of large data bank with a little bit of CockroachDB programming. How's the music? Is it a little bit too loud? Veil Threat Veil, just here for the sweet intro tunes. Yeah, they're sweet, but I don't want them to be too loud, you know? I'm gonna turn it down a little bit, I think. It's loud in my headphones. Don't know how loud it is on the stream. Bro Honster, nice to see you. What's going on? So, yeah, I think I was gonna take a look at this little project I've been working on today, try to finish it up. It's called Create Table Like. And depending on how that goes, I'll probably move on to working on partial indexes again, which is something that I still haven't finished. I've been working on it for too long and I still haven't finished it. What'd it do? That is a great question. I was gonna start off with that actually, so thanks for asking. So basically, the idea with Create Table Like is that it creates a table like another table. Super smart, super cool. So let's give a quick example. So we'll make a table with a primary key and some other column. And if I say create table B like A, whew, what's it gonna do? Well, first it's gonna print out some debugging stuff, but the main thing is that it should have created a table that includes some of the same definitions in the other table. So you can see that it got an A column, it got a B column. It didn't get the primary key column, or the primary key constraint, I guess, because the way that this like thing works is that by default it only gives you columns. It's kind of weird. I don't know how I love it, but just for compatibility with Postgres, we're gonna kind of stick with their semantics. So if I wanted to get the constraints from the other table, we can make a new one and we can say including constraints, or including indexes maybe, and I think this will give us the primary key from the other table. So that's like pretty cool. I'm a fan of it. I think that it's good. I think this is kind of a bug. I think that the nullability stuff is only I actually can't remember. There's a couple of like weird semantics here. For example, if I wanted to include constraints, according to the definition of this thing, it only really means check constraints or something like that. I think nullability is included by default and foreign keys are never included or something. I don't know. It sort of seems like a half finished feature, to be perfectly honest, but hey. So let's do another example. Create table D, and we'll give it a bint, cint. We'll give it a cint check C is greater than 10. I think that's how you do a check constraint. And I'll do an index on B and C. And then I'll say I'll actually say like A int references A of A, like this. And if I said create table E like D, including constraints, including indexes. I don't know, man. It's a little weird. Then I think I'm gonna get a table that has the check constraint and the indexes, but not the foreign key constraint thing. Create table E. Ooh, but it has this auto FK index. Okay, so this is like definitely a bug. This is something that I should fix. Another thing that I should fix is that this row ID thing is included. The reason that this is here is that I think I actually already fixed this. I just need to recompile. In create table D here, we don't have a primary key, so it automatically generates this row ID thing as a hidden column. And we want that, of course, since in E we also don't have a primary key. The thing is that like, we want it to stay hidden. And I think what's happening here is that the like is noticing that there's a row ID column here and just porting it over to the second one without removing the hidden attribute, something like that. Okay, so there's like a couple of little things, and this thing definitely shouldn't be included. I don't exactly know how I'm gonna avoid including this because I'm not sure if there's a way to notice that an index was auto-created. Although maybe it should be included. I think it actually should be included, because I think with this including indexes thing really should probably just include all the indexes. Anyway, okay, so let's like look at what's going on with the code here. Basically, well, actually, before we do that, let's just quickly rebuild, because I think I might have fixed this thing with the row ID. Really, where I left off is that I was writing tests for this thing, and I noticed that there's still a little bit of a bug. So I'm gonna run the test and show off the bug in a second. But I'll kind of go through like the way this thing works really quick. It's quite simple. It's like pretty nice, honestly. Basically, inside of this thing, this is like the implementation of create table. And the way that this works is that it loops through these defs. And these defs are kind of, it's sort of this syntactic AST stuff. There's like a node per kind of def, and a def, there's like several of them in a create table statement. This is how this column table def is like, make me a column, or create, this is like the particular way of specifying a column within create table. This is a particular way of specifying indexes within create table. Column families, this is something that I haven't added to the like thing yet, but maybe I will add it. Foreign keys, like we said, we're ignoring. Check constraints, and this is sort of this new one, this like def thing. And so anyway, like the way that these things get processed at create time is basically that we loop through these defs and we do something per def, sort of in several different places actually. But the very simple thing that you can do to make like work is that write it up front, instead of kind of having to do anything fancy by manipulating the descriptors or the sort of catalog elements that live inside of the descriptors. We just kind of transform the old descriptor into these defs, so that the same code that works for any def will work for the like defs after a little bit of pre-processing. Yeah, I think I didn't exactly update this exclamation point project thing for this little like prelude, but maybe we'll see. Yeah, maybe I'll update it later. I'm not sure. Anyway, right. So what we do is up front, we loop through our defs. We try to find any like table defs, and if we find them, we try to grab the table that they're related to, and we sort of process these options. And these options are kind of fun. Basically, it's like the syntax lets you let's recreate our little example here. The index sort of, the syntax sort of lets you specify unlimited of these including excluding directives. So I can say including indexes, excluding indexes, including indexes, or something like that. Or I think there's also including all, then I can exclude something again. And then you have to sort of turn this into like a bit map is what I did. So that it just sort of listens to the most recent directives in a sense. Kind of funny. So it's not done in the grammar, it's done like later. Let's see, I think, yeah. So this no longer has the, this no longer has that row ID thing, because I think I fixed that as a bug. I should probably add a test for this. But anyway, yeah, so I'll just go through what happens here. We kind of process these options into a bit set. And then for each of the columns, which are always added no matter what the including excluding status is, we skip these hidden columns. That's what I just added. We add a column table def. So this is sort of an AST node that is adding a column. We set its nullability. We add default expressions if we're dealing with this default expression thing as an included option, I guess. And likewise for computed expers, if we have some kind of, if we have this sort of including generated columns business, we actually do include the computed expression in our column definition. For constraints, we just deal with check constraints. And then this is sort of a section for indexes, which has to come afterwards for some reason, basically because the indexes are not per column. Anyway, so that's like kind of the outline. What I was just doing is I was adding kind of a test that sort of operates over this sort of mega table here and does different subsets of these including or excluding options to make sure that the resultant table for each of them only includes the attributes that we expected to copy over from the other table. But since I just noticed that thing with the hidden column, I'm also going to add another quick test to make sure that at the bottom, we can just do it. We'll just make sure that these hidden columns don't get automatically added. So we'll add basically hidden columns in Cockroach mostly just get added right now when we have no primary key. So we'll just add a quick table that doesn't have a primary key, like no pk, a int, b int. And then down here, we'll say statement okay, create table. We'll say like no pk row ID missing. And we'll say like no pk table. And actually, maybe we could use this one to hello crypto Psy. Thanks for tuning in. Maybe just we can also kind of shoehorn in another test case here, which is that you can also continue to add new columns to the definition, which I think is pretty cool. So if you wanted to make it sort of like this table, but also have some new things, I can also say like C int, and then maybe I can add a new index on BC, something like this. That's kind of cool. And then we'll test it as well. So we can do our show create query TT, show create table like no pk row. This is a mouthful of a table. That's okay. So hopefully, like when this test regenerates, it'll actually include what we want. But in the meantime, we're still actually trying to get this thing to regenerate because I still have a bug somewhere that I need to resolve. And that's what we're going to do. Yeah, so what is this bug? What is this bug? It says that column something something not found for constraint. And basically, I did a little bit of pre-investigation into this. This is like this internal column that gets added when we do sharded indexes. Sharded indexes actually, this is a really cool feature. I should make a video about this because it's just so cool. Basically, it's a thing that lets you, I'll just do a quick example to show it off. Basically, let's say you had some table with a primary key with a composite sort of primary key, actually. So we'll say primary key A, B. And then we also sort of wanted to have an index over B, but we wanted it to be, actually, wait a minute. What's the best way to say this? Let's say it's sort of, well, maybe the example here is a bit more sophisticated. But let's say we have like, let's say we're having sort of a prefix by region, and later we configure the database to kind of partition the data so that data that has a particular region only lives in a particular region, something like that. So we'll just do it like sort of a fake example like this. So region int, and we'll say some like ID int or something like this. And the primary key would be region comma ID, which normally would mean that the only way to look stuff up by ID is if you also knew its region. But we recently added this feature that's super cool, where I can say index ID using hash with, what's the syntax for this again? With shard count, I think, with shard count equals 4. Does that work? No. Bucket count, maybe. Oh yeah, and it's also experimental, so I have to turn on a setting. But basically what this does is that it automatically sets things up so that I can still query by this ID directly. But under the hood, the database is doing this sort of hash sharding magic to make it efficient under the hood. So I can show it with an explain. If I say explain select star from A where ID equals 3, normally the way this would work is that it would have to do a full table scan without this index because there is no index on on ID. And normally also making this index would make sort of this global index that isn't partitioned by anything, which is sort of inefficient for a couple of reasons. But the point is that since I've got this hash index, it's actually doing this kind of crazy thing where it hashes the ID that I'm looking up and uses that as a prefix. So if I change this number, we should also see these spans change. This is saying that like this ID 3 fell into bucket 0, so we're looking up into this sharded index bucket 0. I think this region thing, I think I got it sort of backwards. I've been doing this on the fly. This isn't exactly the use case you'd use it for, but whatever. If I make a video about this, I'll make it a little bit more clear. And in this case though, since ID is 4, maybe it hashes to 3, so that's why we get this different span. But anyway, total side note. The point is that with create table like, these things don't really play nicely together. So as another example outside of the tests, I could do this, I could do this. And if I made another table B, and I said like A, I think this is gonna return an error. Whoops. I have to say including indexes. Including indexes. Yeah, so I mean, this is like super broken. The tests are broken for another reason. This is broken for a separate reason. Yeah, so let us deal with it. Let us deal with it. So the first thing that we're gonna do is jump back into our implementation here. I have this special case for it. So if it's a sharded index, we do something different. Oops, sorry. If it's a sharded index, we set our so this is kind of like the descriptor that we're reading on disk. This is like the one that we're trying to copy. This index def thing here is the one that we're trying to emit as our new table. And so I thought that this would kind of work, right? I'm saying that set the sharded specifier thing on our new index to this sharded index def, and I'm giving it a shard buckets, and I'm setting the shard buckets to the thing that's inside of the index. So I don't know. I mean, don't exactly understand right now why this isn't working actually. Maybe we can just start printing stuff. That's always an easy way to get started debugging things. So let's do it. Let's just print out what we've got so far over here. Actually, we'll do it at the end. We'll say adding index def dot there's some like as string thing. Tree.as string. Index def. This has to be a pointer. All right. Yeah, I'm based in New York. All right. Cypher TV. Cypher TTV. Hello. How are you doing? How are you doing? I'm doing great. I'm doing great. You're doing great. I'm doing great. I'm trying to debug this create table like thing. Keeping safe. Yeah. Things are fine. But we're not going to talk about coronavirus on stream. That doesn't sound very fun. We're just going to talk about programming. But thanks for asking. Spit some freestyle. I'm not up to that level either. Not up to that level at all. Maybe you should do that though. I would watch your stream if you spit some freestyle on stream. That would be awesome. That would be super cool. All right, so let's see what happens now. Whoops. Need to make my table. Need to make my other table. All right. So what's the deal? The deal is that this is messing up. It's confused. It's somehow adding a second column into this index, even though I've only specified one. I kind of have a hunch on why that might be happening. But this is looking good. This is looking just fine. So I'm a bit confused about why it might be complaining that bucket count must be strictly positive integer value. Because it looks pretty positive to me, right? You want to become a software engineer. That's great. I think that you can do it. Anybody can do it, I think. You should start now. There's no time too soon. There's so many programming resources out right now. Oh my gosh, it's just wild. Go to the internet, look on you can start learning Python. Python's, I think, a great new language for not new language, a language for new programmers. You could look up some Python tutorials, get started. I believe in you. Yeah, Python, I think that's good, man. I think Python's a great place to start. I would recommend it to anybody. Right. So what's the deal though? What's the deal? Where is this thing coming from? Must be a strictly positive integer value. Must be a strictly positive. This is happening over here. Oh, I see. That's kind of funny. All right, so basically, yeah, this is Go. Basically what's happening here, it's sort of this thing that's specific to the way our parser works. And I'm wondering, this might be something that I could fix actually about this bucket count implementation thing. I think what's happening here is that we expect A-expers. So an A-exper in our parser, this thing is our parser. This is kind of like the way that the SQL language is generated for CockroachDB. It's sort of a list of specifiers. You can build up a grammar. It's a whole kind of part of the world of computer languages. But point is, this is sort of like where we're getting that syntax from. And it says that if you, wait, maybe there's two of these actually. Yeah. If you say using hash with bucket count, the thing that you pass into it is what we call an A-exper. And an A-exper is kind of like the most general kind of expression, scalar expression that you can do in SQL. And I think what's happening is that even though we let the grammar, or sort of let the user put any general expression here in the grammar, we still are expecting it to be a numeric constant. So that's kind of goofy. So for example, I think if I said create table D ID end, then I said index ID using hash with bucket count equals, and then I said something like, let's see, what would be something that wouldn't get evaluated immediately? I wonder if I'm allowed to put a subquery here. That would be sort of funny. Let's just say select one, see what happens. I think this is gonna fail. Yeah, and the reason is that we allowed things to be an A-exper, but we don't actually ever evaluate them, which is, we can fix that. That should be easy to fix. What do you think the main languages used in the workforce? I mean, look, it depends a lot on what company you're looking at, what kind of thing that you want to do, if you want to do front end or back end, or yeah, you know, I think the reason that I like Python for new programmers is that once you learn Python, that's going to be such a solid foundation for you to learn many, many other languages. I think that programming languages are sort of like, I don't know, how would I say? If you sort of know one language from each sort of general class of languages, you can generally get by pretty well. It'll be easier and easier to pick up new programming languages the more that you have under your belt in the first place. So learn Python, then learning Go won't be so hard anymore. So I think starting somewhere is always good for anybody. Not such specific advice, but I think it's true. So I think anyway, for this, basically what we want to do is instead of asserting that this thing is a numval, which is basically not the right thing, we want to actually evaluate it. The only little tricky bit here is that in order to evaluate scalar expressions in Cockroach, you need this thing called a eval context. So I think really what I would want to do here is say shard buckets dot, oh, I guess I would have to type check it too. So I would have to type check it using this semi-context thing. I would say typed exper is equal to this, and then I would say typed exper dot eval, and then I give it this eval context, and then I could say this thing has to be an int. Let's see, is that really possible? Do I have all the right ingredients? That's kind of the question. For ethical hacking, I don't really know too much about ethical hacking. That is never something I don't know really about that. I think you might mean, yeah, I don't know too much about that world, unfortunately. So no good advice there. I think learning Python's good no matter what though. So just do that. But look, we're lucky we have a sema context and an eval context. Those are the ingredients we need to type an expression and then evaluate it. So that's great. And we can pass them in. We can pass them in. So we'll do that. We'll say sema context. We'll say eval context. And then I think we probably need to change the call sites for this as well, but we can do that in a little bit. This thing needs a sema context. In this case, since we know we need a strictly positive integer value, we can say to this type check method what we want, this desired types thing. We can say types.integer, types.int, right? And I think this is going to say, no matter what shard buckets really is, if it's not an integer, I'm gonna fail. Actually, I think there's actually even a better method called type check and require, something like that. Yeah. So this takes a CTX. Sema context, I mean, it takes an expression, which is our shard buckets thing, and then it takes this required thing, but it's gonna be types.int, and then I think it takes a little string, and this is gonna give it a pretty error message if we mess it up. So we can say, like, what would be the operation here? I guess it would be shard bucket count, something like that. And this is also gonna give back an error, and of course, since we're in Go, we'll say if error not equals to nil, return 0 error. You'll get used to saying this if you're learning Go. Cool. So we've got our typed expression, then we get to evaluate it using this thing, eval context. And at this point, we actually know, and then the same thing over here with the error returns. At this point, we know that this has to be a dint, I believe, because I think this guarantees basically that this thing is going to be a dint, which is what we call an integer in the internal type system in CockroachDB. So what we'll say is, we'll say CST as int32. I think we can say buckets is equal to must be dint. And then we'll give it this D thing. Right. Then we can get rid of all this stuff. Get rid of all this stuff. I guess over here we really want to say we can actually just override this error message that type check and require will give us back, since we have this like special invalid bucket count message thing, and we'll just use this guy. Do that over here. And actually, yeah. We could wrap it. That's the cool thing to do. Wrap. This will actually, well, yeah, we might as well wrap this. We'll see what happens with that. But I think it's good. Same thing over here. And then at this point, we can say, get rid of this. We'll say if buckets is less than or equal to 0. Yeah. Cannot use int as type int32. Cool, okay, so this was a bit of a side. It was a bit of an aside, not gonna lie. But I think it will improve our life quite a bit. It'll fix this bug, maybe. And it'll also let us do cool things like this. I think this will work now. Let's try it out. So we'll be able to do the extremely useful common operation of wanting to create a hash sharded index with a bucket count that's created from dynamic value. That is just such a useful thing. Such a useful thing. I'm being sarcastic. I don't think that that's that useful. Okay, something didn't work. Oh, it's because I forgot to change the call sites. That's fine. We'll do that next. We will do that next. So let's see. This now has to be edited in all the places. Your first open source contribution was to CockroachDB. It was a small change, but you're still proud. Dude, that's awesome. That's so cool. I'm very proud of you. And thank you also for contributing. That's great. I think that, I hope you had a good experience with it, and I wish there were more people like you in the world. When am I gonna do quantum query optimization? I don't know what that means, Scythe. You tell me. You tell me what that means, and maybe we can do it together. I have no idea though. All right, so let's go ahead and change all these call sites. I think we just need to pass in sema context and eval context. Oh, but maybe this guy doesn't have it. So we'll do a little bit of a threading problem together. It's super fun. It was a great experience. I'm really glad to hear that. That makes me happy. Okay, so this thing needs settings. I think instead of settings, we can just pass in the eval context like so. And then we can get the, do we do this anywhere else? The setup sharded index. Oh boy, we're gonna have to do some really, really fun stuff right now. Really fun threading stuff. Not really so fun, but that's okay. That's okay, we'll do it together. So this is gonna now be an eval context. Eval context, eval CTX, eval context. Right? Now we'll go change the call sites. Wait. No, we also need a sema context. Sema context. Now where does that come from? I think that also comes from the planner, hopefully. Sema context. Yeah. This sema context thing, it's sort of for type checking. I don't know. It's sort of, I don't love it. The fact that we have to deal with it every time, it's annoying, but that's okay. So we'll say settings equals eval context dot settings. That fixes that. Now we can go change these second two. Okay, params dot. Uh-oh, wait, do we have a sema context in this run params business? I guess we can get one. Yeah, we always have the sema context. If you have the planner, you have everything. So you're good. All is well. Third use case is over here. What do we have here? Over here we have them right available, so we can say eval context, comma, sema context. What's wrong with this? Forgot a comma. All right, I'm a little bit slightly nervous that this settings things came from something else besides the eval context, ST. See, why wouldn't you just get the settings from this? I hope that there isn't some sort of other. If there's two cluster settings running around, that would be really unfortunate. I'm just gonna assume that there's not. Maybe things will break. But maybe they won't. Okay. Okay, so now we get to pass this thing in finally. We can say sema context, eval context. And then I think our dreams will have come true, almost. We just have to do it 2 more times. Sema eval. 1 more time. Sema eval. Oh, we don't have one here. Why? Why? That's frustrating. That's frustrating. That is really frustrating and not super fun. So what is this? Make column def desks. Creates the column descriptor for a column as well as the index descriptor if the column is a primary key or unique. Is there any reason why? Maybe it's just that before there's never been a situation in which we were supposed to eagerly evaluate a definition in one of these things, and that's why we don't have an eval context here. But I don't think that there's like a strong reason why you wouldn't be able to. Well, let's just pass it in again. More threading. Really fun. Really fun with the threading. Params dot, no wait, yeah, params.p dot, params.eval-context? Params.eval-context. Yeah. We'll just do it. Why not? Why not? Just go buck wild. Everything can have an eval context. I need one of those GIFs. You have an eval context, and you have an eval context. That's how I feel right now. And we can just pass dummy ones in tests for sure, because nobody's really testing these hash-sharded indexes in their random unit tests. This is another test. Why not? Just pass nil. What could go wrong? What could go wrong? In your test, if you add. All right. Okay, just one more. It's shaving yaks. It's shaving yaks. The more things you change, the more things you have to change. This is now gonna have to get an eval context. That's okay. Okay. Sema. Init virtual table desk does not need an eval context or a sema context because it'll never have a virtual table with a hash-sharded index. That's probably true. That seems fine. All right. So what now? What now? This is named wrong. And this is, I think, the final piece. The final piece. Maybe. Something's unhappy still. All right. All right. Let's see what happens. We'll try to compile this again. Will it work? Any bets? My bet is maybe. This is looking like a maybe yes. This is looking like a maybe yes. Then we can go ahead and do our cool random yak shave test. Make sure that we can make dynamic hash bucket numbers. Super useful. Probably should have just written a test for this so I don't have to recompile the whole database, but hey. Never celebrate early. Oh man. I should have learned that lesson by now too. All right, let's go though. Let's go. Let's go. I almost got dismayed, but I think this is fine. Oh! You're right, I shouldn't have celebrated early. Caused by, was the underlying expert type checked before asserting a type of type expert? Yes, I thought it was. I thought we did that. You know, I really wonder. I wonder whether any other create table statement even allows you to put subqueries in it. Have I just gone wild? Have I gone too crazy for this? What other create table statement could possibly use? You know, I bet that in other places we just ban that completely. So for example, we could say ID int. It's like, here's another thing that could take a check expert, I think. ID int, or an A expert inside of a table desk. ID int check. ID is greater than select one. This is definitely gonna be banned. Variable sub expressions are not, yeah, this is what we want. We want this, we love this. We want this for ourselves in this hash sharded thing. Variable sub expressions are not allowed in, sanitize var free. This is what we want to do. This is what we want to do. We want to do this for our hash sharded index thing. Where is that at? Where did it go? It went over here. Yeah, we could just do it right here. Why not? Oh, but we can't import that here. So we'll have to do it somewhere else. Pretty annoying that we have these things scattered all over the place, huh? I find that annoying. Why is this scattered in 4 different places? Set up sharded index, make table desk, make table desk. I think what we want to do this is do this like way up top when we notice that anybody has touched this shard buckets thing. Interesting. I see. The problem is that we have them in 2 spots because of this primary key business. We've got the primary key can be specified in a column, and that's one place that you can put shard buckets. And then the other place is when you specify an index. And then maybe a third place is when you specify an index all on its own. So I see that's understandable, I guess. So let us see the proper place, the proper place to call this sanitize thing. Sanitize var free expr. Normally, we're calling this inside of make check constraint, which is right in make table desk. Okay, this seems good. So we'll do it sort of way up high. We'll do it way up high. We could do it here, for example. Yeah, we'll just, ooh, what about doing it in setup sharded index? That could be a cool thing to do. Because I think that's called by all the places, hopefully. Let's try that out. So we'll say up front, we'll say SQL-base.sanitize var free expr. We're gonna give it this buckets expr. We're gonna require it to be types.int. Why is this unhappy? Types.int. We'll say it's a bucket count context. Yeah, no, false, error. Okay, so let's make a test for this so that we do not have to recompile everything. I bet there's already a test for shard test data. Yes. We'll make a new one of these. We'll say with bucket count equals select 1, and this should fail. With what code? I don't know. Let's just put something in, see what happens. Make test base logic files equals hash sharded index. Let's see, is it gonna work? Oh, it's because I changed the error code for some other thing. Found code. Okay, 22003 was what again? 22003, numeric value out of range. I guess that's fine. So I think what's happening here is that 2203, 2203, 22023. Oh, I see. I just like edited something by accident. Probably. What did I do? What did I do? What? 22003? Numeric value out of range. Did I remove something that said numeric value out of range? Numeric value out of... I did not. So how come this changed? That's my question. Line 23. Oh, it was this one. I see. Was it this one? Let's run that one more time. I'm confused. I am confused. Expected error code 22203, but found code 42804. Oh, this is actually neat. I think what we've done is we've enhanced things. Because in this case, we don't have an integer, and our type checking was slightly, yes, exactly, float to int. Our type checking was enhanced. Things are better now. This is cool. I don't think that we really need to assert the PG error code here. I feel like that's like super strict for some reason. Why would we do that? Well, let's just do it. I think this is still gonna fail because we've probably changed the error message, but let's find out. And we'll just put a single test config right now because that was going out of control for no reason. Cool. Expected error code 22023, but oh, right. 42804 is our new code. 42804. Let's see. Is it gonna be better? Okay. So this is back to our thing that we were trying to fix. And the answer is that it's still panicking, probably because we only changed it. We didn't sanitize var-free expr in the right spot. I think we maybe sanitized it in one of the right spots, but not all of the right spots. That would be my guess. So let's go fix that again. I think we realistically have to call it before each of these, which is irritating. Oh, you know what we could do? We could actually just move this whole definition into SQL so that we don't, yeah, let's do that. Let's move this into a different package, then we can call sanitize inside of it, and then we should be just happy. Let's use the fancy move thing so that we don't have to, wait, isn't there a move thing? I thought there was a move thing. Isn't it like,
Welcome to VoiceOver.
oh my God. That was
VoiceOver speaks descriptions of items on the screen.
not the right button. Yeah. Okay, I forget the key combo for moving, to be honest. Move. F6, it's just F6. Okay, so we're gonna move it to package SQL, and we'll put it into file. We'll just put it into file. We'll just put it into create table.go. It should be fine. Unexported type check and require will no longer be accessible from variable typed expr. But this is going to be okay because now we're calling this sanitize var-free expr thing, which I think already does type check and require, maybe? Anyway, we'll see what happens. Okay. So it made a file called createtable.go.go, which was not exactly what we intended, but that is okay. We will move it. We'll move it and just like stick it in here somewhere. This is a giant file. This is embarrassing, but that's okay. Never got used to Goland. It's great. I mean, it does take some effort to learn. I know it pretty well because I used to use IntelliJ, and IntelliJ is the same thing basically. It's good. It is a lot faster than using other things. What editor do you use, out of curiosity? I mean, I don't really care. Everybody has good reasons to use editors, so I'm not gonna be a zealot, but which one do you use? Vim, yeah, I respect, man. Respect. I am also a Vim user. I just can't use Vim for this big of a project though. That's my problem. It's just, there's too much going on. I need the fast indexing, fast jumping. I would just go crazy. I tried it for a while and I couldn't get it to really work for me. Okay, so sanitize var free expr. Where did this go? We moved it somewhere, so let's grab it and setup charter index. Here it is. So just grab this whole thing and stick it into that other thing. Man, this is just an absolute huge rabbit hole. But that's okay. Okay, so this is gonna take the shard buckets. And this, I think, does return back the expr, right? Yeah, it does. That's great. See, this is just gonna improve our lives for sure. So we'll call it bucket. Bucket expr. This thing will return 0, error. We'll get rid of this. We'll get rid of this. No, we need this one still. Bucket expr. Blah, blah, blah. Like failing my key combos right now. Okay, we'll call this typed expr. We'll call this buckets. No, well, we'll just leave it as it is. We know this is a datum. That's fine. All right. What were we doing? I think we're probably happy now. Maybe. Are we happy now? We need to delete this stupid .go file. Is that still there? Yeah. Let's run our test again. I probably forgot something. Probably forgot something. Oh, Lord. What did I do? Import cycle. Jobs PB imports SQL base. That is absolutely not going to be allowed. How did I let that happen? SQL base. Search for this inside of this. Oh. Oh, maybe that is allowed then. So I'm confused then. Logic test imports this, this imports this. Oh, SQL base imports SQL. That's not allowed. Okay, how did I do that though? How did I do that? Git diff. It's probably some change to this thing, right? Yeah, this is a no-no. Big no-no. Oh, because I need it in here. Frustration. So I guess this thing, does this thing need anything from SQL? No, this thing lives, okay. So I just needed to move this to SQL base and not SQL. That's fine. That is fine. What is this dang? Okay, here it is. Copy, no. I have to do it using boring action. It's F6, okay. Move this to SQL base. And the file name, what would it be? Maybe just table.go. And we won't make the mistake of putting .go at the end because apparently it doesn't like that. What? I think this moving thing, it just doesn't really work that well. It just doesn't work that well. I should just do it by hand every time because it's just so easy to make a mistake like that. which is just super goofy. All right, fix this. This thing is just absurd. We can delete it altogether. We'll just delete it from the terminal. rm package SQL. What did I say? Package SQL base? Yeah, it's goofy. All right, so now I think, except how come this isn't used anywhere? I don't know. Eval, shard, bucket, count, SQL base 2. Oh my gosh. SQL base 2, that is just horrendous. At Cockroach, is it common for managers to also write day-to-day as well? Most eng managers focus on people-related stuff. I don't know since I'm still in school. I would say that most of my job does not involve writing code. I think that I still like writing code, and we have a thing called Flex Fridays at Cockroach Labs, which is pretty cool. So on Friday, there aren't any really meetings necessarily, and you can kind of concentrate on something that is not necessarily your day-to-day job. So luckily for me, for that, I can do some programming, because I like that still. Doing it on stream is fun too. That's sort of newer for me. But yeah, most of the time during the week, no, I'm not really doing too much coding, or really any coding at all. I think I still do a bunch of code reviews, but not too much programming during the week. All right, let's run the test again. Shard bucket count. I want to do a video. I want to do a video on these hash sharded indexes. I think that would be really cool. We should also, I mean, they're marked as this experimental feature. I don't exactly know why. I guess it's because we haven't tested them enough yet, but I mean, they're good. They're really good. Wow, this directory is just littered with crap. I should delete this stuff. I think one thing that would be fun to do on stream too is some performance evaluation. I'd like to do that at some point. Not evaluation, like analysis, I guess you could call it. I like spending time doing perf analysis, and it would be fun to do that together. Okay, bucket count must be a strict, okay, expected this, but God, oh, this is so much better. Look at that. That's like a more advanced error message, so I'm super into it. Let's now fix the expected error. We'll just copy and paste it, honestly. That'd be quite useful. Do you program in Go? I think it's like medium Go specific, I would say, this tool that I like to use, pprof. But I guess they actually also have it for C and stuff. I just don't know how to do that. Nice, okay. We are making some decent progress. There's always this feeling when you're yak shaving where it's like you kind of dive deep into this random corner of something that you never expected to work on. And then it keeps going deeper and deeper and deeper. And then once you finally get to the end of a chain, you can sort of feel yourself coming back up the chain, and that's a good feeling. So that's how I feel right now. I fixed one of the problems at the end of the yak shave, and now I can come back upwards. It's a stack, maybe. So the point is that, maybe we should make a little commit with this to make our lives easier later. Make a branch, get checkout -b. We'll call this, well, eventually it's going to be create table like, but for now I think we'll make a branch just for, we'll just make a create table like thing, create table like branch. Haven't programmed with Go professionally yet. Yeah, it's a language. So we can make a commit just for this sharded index stuff. we'll skip all this. This is parser stuff. Skip this, skip this. Ooh, I think we need that one. All right, let's start again. Skip, skip, skip. We want this, we change this, change this, we change this. All this threading stuff I think we changed. Format? I think that's probably just for debugging. No, we need it for the sprintf. Okay, so we want this, we want this, we want this, we want this, we want this. We also want this. It feels very intuitive. Yet, I mean, it's intuitive. I think the thing with Go is that it's very straightforward. That's the word I would use. It's like, there's no trickery. There's no functional programming. There's not that much abstraction. There's no generics. I mean, that's something that can be confusing in languages with generics. So it can be straightforward until you want to go crazy, and then it gets unfortunate. It gets a little bit unfortunate. Grab all of this stuff. Oh, we don't want that one. Had to work with Scala. Co-op. You sound like a Waterloo student. I think that Scala is a pretty confusing language too. Don't want this like thing. Don't want this thing. You are a Waterloo student. Why not rewrite Cockroach in Rust? Well, I think that would be a pretty big project. I also, rewrite it in Rust. Is that a good idea for a database that has been in progress for like several years? I don't know. I don't think so. I don't think that would be a good use of time. But to be honest, I'm not much of a Rust. I'm not very knowledgeable about Rust, is the thing. I think there's some people who love it. I personally don't have enough experience with it to know whether I love it. But it seems cool. I mean, it seems fast, right? If you know, figure it out, if you can spend the time that you would need to spend in order to understand it, in order to kind of get all that lifetime stuff set up. I don't know. I don't want to say too many things about Rust because I don't know anything about it, but it does seem like it's a bit slower to write than some other languages. All right, so we want this. Skip this, skip this, skip this. Don't want any of this stuff. I think this stuff we all want to skip. Same here, I dabbled it with, but I'll stick with C, C++, and Go. Solid choice, maybe. I want to learn Rust. I always like learning more languages, to be honest. It's fun. I kind of tried to learn it at one point, but then it didn't stick because I didn't use it for anything serious. Okay, so I think that is our good commit. I think I added one accidental thing in there to do with like table, but mostly this is good. So we'll say git commit, and we'll say, we'll call it SQL improve type checking of bucket count for sharded indexes. Well, we'll just say small improvements to sharded index creation. Hash sharded index creation? Small. Now we play the game of trying to make our commit message short enough to not have this other thing. Small, slightly improved. Yes, okay. So there's two things that we did. We improved type checking and bucket count for sharded indexes. And also we ban, make sure that users don't accidentally, let's see. So what did we do? We kind of like, I did this off stream, but basically the sharded indexes, they make these hidden columns. And if somebody was to create a column with the same name as the hidden column, things would get kind of screwed up. So return an error if a user happens to name a column the same thing as one of the hidden columns for hash sharded indexes. All right, and I want a release note. The release note here is like basically nothing. Release note, SQL change. I guess it would be like users can small UX improvements. Oh my gosh, it's so specific is the thing. To hash sharded index creation. And I think we left in one thing by accident to do with like, so I want to remove that using some magic git stuff. So we'll say git reset. Ooh, I'm a little scared because what if nothing's fine. Git reset -p head thing, and we'll kind of delete this. And we can search, no other hunks to search. We want to search for the thing where we accidentally added like. Not here. Here it is. So we want to remove this guy, then quit out of everything. And then we can amend this guy. And then I think we were able to, yes, okay, cool. Hey, Paul, this project is a bit out of date. Currently, I would probably like to update that. I should figure out how to update that on the fly during a stream. But what I'm working on right now is adding create table like to the database, which is a feature that lets you create a table with similar features to another table, such as columns, indexes, constraints, other things like that. But I started getting into a crazy yak shave to fix a bunch of other stuff as one does. So right now I am fixing a little bit of a problem with this other feature called hash sharded indexes in the database, but I think I just finished with that. I think I just finished with that, hopefully. We added our test, we made a commit. Did we add our tests? We did. This was our test. And I think we're good to go. So let's get back to what we were doing, which was running the tests for the like thing that was broken because we didn't fix this other thing. Make test-based logic, blah, 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 blah. We'll call it create table. And we'll also just specify a single test config this time. Cool. Is my thing blinging in everybody's ears? That would be obnoxious. Let me make sure that that is off now. All right. So this is back to the original error. The original error that I have not yet figured out. It's blinging right into your ears. I'm sorry, it should be done with that. I think it's not gonna bling any longer. How's it, here, since you're talking about the sound quality, I'm curious from your perspective, how is the mix between my voice and the music? So this is the error that we're trying to figure out why it's happening. To me, the mix sounds quite good. Hell yeah. That is great to hear. Thank you for that feedback. I appreciate it. So let us, I think here's what we're gonna do. We're going to separate these test cases into two because this test that I added is too complicated. And before we actually fix all of it at once, I would like to know that even our base stuff is working. At the moment, we don't even know if our base stuff is working. Instead, we just have this massive test here that has all sorts of variety, and we're trying to sort of make sure that everything is working with this create table like business. But this hash thing apparently is complicated, so I'm just gonna comment it out for now, and I'll add another test case with it later down below. Let's just see if this works on its own. It does not because you cannot put a comment into SQL. I should have known that. That is basic. Try it like this. Okay, so yeah, we had some other problems too. That's good, I think. So this is on line 145. It's saying, oh, this is an interesting one. This is an interesting one. So what's happening here Since I think I talked about create table like way before most people on the stream joined, I'll refresh everyone's memory and say that create table like allows you to copy a table definition, including only certain parts of the table definition. And you do that using these including flags here. And there's a bit of a variety about what is allowed in these including flags. And you can sort of bitwise them as well. So you can say, this gives you everything, and you can like turn off various things after you included everything, blah, blah, blah. So the thing that I wanted to kind of talk about though, or the thing that's broken in this particular case is that here I've asked to include all indexes. But the thing is that without including so-called generated columns, we don't include columns that look like this, C decimal as something stored. What this is saying is that this column C is actually a computed column based on the definition of A. It's saying, make a column that every time somebody inserts something into A, insert the value of A plus 3 into this C thing. And so it's automatically done. Nobody ever has to touch it, and so on. But I think what I did is that if I don't include generated columns, I don't even include this column at all. But I think what I really should be doing is saying that without generated columns, the column is there, it's just, it doesn't have this stored specifier. I think that's what I'll do. So to fix that, it should be very straightforward. I think I just put a continue in a bad place, basically. Generated, where does it go? So here's our code that does this. It says, if I have a computed expression on the column that I'm copying and my options doesn't have this generated thing, I'm just skipping the column altogether. But instead what I want to do is probably invert this a little bit. So if I have a non-nil computed expression and I've got the option, then set the option on the new field. I think that'll probably fix it. Let's recompile and try our test again. Sounds perfect. I'm glad. Thank you. I should save my levels so I don't have to worry about this every time I do a stream. That would be smart of me. All right, so we're running these tests again. And hopefully what we'll see is that in this particular output, rather, we won't get an error. That's the first thing. And the second thing is that we'll have these indexes, but this particular column won't have a generated expression associated with it. Ooh, we should get rid of these printouts. That's no good. That's not very cool of us. Added index def. Actually, we're gonna leave them for now. Always a bad idea to get rid of debug print lines before you're finished debugging stuff. And we are not finished debugging stuff probably. Okay, so let's see what got generated. These tests are cool because when you run them, they will automatically generate their output based on the current state of the code. So that's a great way to start with test cases. So let's go through them one by one. I think that's the plan. So in this first case, we're creating a table like another table without any of the including specifiers. So the only thing that we should get is the column definitions, and that does appear to be what we got. We don't have any indexes, any constraints, any generated columns, any defaults, anything really. So that seems correct. This next one, we've got constraints according to the specifier, and down here we do in fact have a check constraint, so that seems groovy. In including indexes, we've got all of these columns. We've got a primary key constraint, which is the same as an index. We've got a unique index. We've got an index with storing columns, and the storing columns appear to be the same. So we're trying to copy this thing, index C storing J, and we see index C storing J. We've got an inverted index here. Yes, great. Okay, so this is looking good. So our generated one now, what's the deal? this should have everything, all the columns, and it's got the generated expression, so that seems good. The default specifier should give us columns plus defaults, so that seems good as well. Including all should give us everything, so we see our defaults, we see our generated expression, we see our primary key constraint, we see our indexes, and we see our check constraint, so that's also great. And here this mixed one is supposed to just check, I guess, that like, I don't know. I mean, I should have a separate unit test for this probably, but it's supposed to check that this bitwise logic thing works. So it says including all, then we exclude generated, then we exclude constraints, then we re-include generated. So it basically should have everything except for constraints. And don't be fooled by this. This gets included by the indexes, not by the constraints. But the point is that it doesn't have a check constraint, so that's good. And I'll put a comment for this. We expect that this table will be missing the check constraint from the first table, but including everything. We'll include everything else. ls. All right. Cool. So now we want to also have this other test to make sure that in this particular case, like, okay, so with tables without primary keys in CockroachDB, we generate a hidden column and create a primary key on that. And we call that row ID. And I wanted to make sure that if we do create table like, it doesn't accidentally show the row ID column. And in fact, it doesn't. I'm noticing something a bit odd though, which is that this is out of order. Wait a minute. Oh, right. This is something, this is kind of interesting. Okay, so this was doing too many things at once. I'm gonna try to chill with the doing too many things at once thing and make another test for this thing that I'm trying to do right now. So we'll do, so the thing that I'm trying to test right now, I'll say a test that mixing normal specifiers and like specifiers works as expected. And so the cool thing about these like specifiers is that you don't actually have to just stop at a single like specifier. You can specify like specifiers as well as normal specifiers. So I could say, why don't we actually refer to our original table for this too? So we'll say create table, like table, or like more specifiers, maybe? Specifiers. And we'll say like table, and then we can also add new columns if we wanted. So we could say C decimal. We could add new indexes if we wanted to, and we could refer to the columns that were already in the previous table. So index A, comma, C. Any other cool things to check with this? I guess theoretically we could mix in another like if we wanted to. Why don't we do that for fun? Create table, other table, d-ent. So we could also say like other table. And we'll put this one here too, just to be kind of weird. All right, and so then finally we'll do our show create to see what that looks like in the end. Show create table like more specifiers. We'll rerun our tests, regenerate that output, and see what is up. Duplicate column name C. Oh, it's because our original like table had a C column. That actually, you know, that's a good thing to test too. I should test that. So we'll make another test case for it. Create table duplicate column. Statement error. What did it say? It said duplicate column name. Duplicate column name. Like table, C decimal. So we're expecting that this should error. That's a good thing to check. Now for this guy, we just want to make sure, so we're just going to rerun the test and generate the output again to see if it is behaving as we would expect, which I think it should. expected success, but found duplicate. Oh, right, I didn't correct the problem. So we'll call this one, let's see, in our original big table, we ended at H, sort of. No, we ended at C. We'll just use something like Z, how about? So if we change that one, we won't be sad later. So we'll make this Z, we'll call this ADZ. And I guess this one we should also rename it to, we'll just call it blah. How about that? How about that? For good column names. Okay, so we'll regenerate it. We'll regenerate it. It seemed to work. Let's see what we have and see if what we have is what we expect. Well, so we expect all of the columns from the original table, which we see here. We see this new column, Z. We see the index that we made. That includes the columns from the 2 other tables. And our new column, Z. Yeah, so I think this is right. The only thing is that the order is different. And I'm wondering if that actually is a problem. I think it probably is a problem, because I think if you were doing this, you would expect that depending on the order of the like within your specifiers, your columns would come where the like is. So in other words, if I wanted to put a Z here, I would expect it to come after all the columns from like table. And if I wanted to put a Z here before this like, I would expect it to come before all the columns from the like table. And I think that's probably pretty easy to fix. And I know where it's happening, so I will just go fix it. So I think it's happening basically right here. So we have this big loop. We're looping over all of the all of these specifier things. And when we find a like one, we process it, we turn it into more definitions or more specifiers, and we add them to the end of our original specifier list. And I guess what we want to do instead is just insert it in the middle of the specifier list. So I think the way that we should do that is by, well, I don't know. Because there's a couple of problems. I mean, one problem is that if I actually edit this end.defs thing, that's kind of nasty because you're not really supposed to edit these AST nodes. They're supposed to stay immutable. Speaking of programming language, this is a great reason that Go is sort of not as powerful as some other ones. I think in some other languages you could say that this particular field is immutable, and then if you try to edit it, it would blow up at you. Whereas right now it's like anybody can edit these things and it'll completely destroy all of your assumptions, which is sad. But since I know about this assumption, at least I can try to fulfill it. Well, you know, maybe it actually isn't so bad, because well, what's the worst thing that could happen? The worst thing that could happen is that during our create, I mean, essentially what we're doing is we're editing. Wait a minute, we're already actually editing it. So I'm already just lying to myself. And I'm already making this thing mutable. And in fact, other people are making this thing mutable here too. Or are they? No, they're saying ensure copy. See, they're being kind. They're being kind. What is the deal with this ensure copy thing? Oh, I see. So actually there's our little helper that maybe, no, we just use it in that one spot. But I guess I could just, as soon as I'm actually noticing that I have a create table like, I could ensure that the node is copied. Ensure that the node is copied and then just carry on with my life. I mean, this also looks wrong to me, for the record. Look, it's saying that if we haven't yet copied it, so create statement is the thing that we're going to edit. n is the original one. We're saying that this, if the original one and the one that we're going to edit are the same, then we're going to make a copy. So we're saying new create tables, new create statement. We're doing this little dance, which just means make a copy basically. And then we're editing the wrong one. So like what kind of crazy, I mean, this just doesn't make any sense. This is a bit bit confusing to me. Okay, it's been here since late 2018. I just think that this is ineffective. But I'm, you know, rather than get bogged down into this, because we've already been bogged down into random things, I'm just gonna note that nobody's treating these end.defs as immutable in the first place. So how bad could it really be if we maybe this is doing what we expect. Hold on. So it's saying this is actually copying into the old one. And then maybe everybody from then on references create statement instead of n or something like that. Dude, I don't know. This is wild. This is wild to me. Because they're just editing n directly. It doesn't make any sense. It really doesn't make any sense. Who uses this thing later? Wait, what? Nobody uses this thing? This is like dead code. This is just dead code. Okay, here's what I'm gonna do. I'm just gonna edit n.defs directly because I'm pretty sure that it will not matter at all. So what we're gonna do is we're gonna say new defs. This is just gonna be so gross though, because then once I'm finished with this, I'm gonna have like some half broken thing that's very similar to this half broken thing. So really what I should do if I was being a kind citizen is clean that up. But I don't know if I want to be a kind citizen right now. I just want to get this working. Okay, here's a question. Let's say you're iterating over a slice in Go using range. What happens if you edit it? What happens? I think the answer is that I don't know. Just don't know what the answer is. Okay, let's just stab forward with intention. Okay, new defs is equal to n.defs. All right. And since we're ranging over this, I think what that means is that if I start editing this guy, at least if I make an entire, what a nightmare. I find myself in a nightmare. I think this is another example of why in Go it's a bit frustrating, because they don't give you any primitives, like, you know, insert some stuff into a list. You have to reinvent it for yourself every time, which is not really so fun, I think. So, okay, let's just say new defs is equal to n.defs. We'll say, maybe we'll just say it's nil. And then if we actually start having to do anything with this, we will actually eagerly copy it or something like that. And I think we have to give it a type. New defs. And what is this thing? It's a table defs from the tree package. Okay. So at this point, we're definitely going to be editing n.defs now, so make a copy of it. If new defs is equal to nil, new defs equal to make tree.table defs. And I guess what we'll want to do is make it just the length of n.defs for now. And but then we'll have to append over here. Oh my gosh, this is just so annoying. I feel dumb right now. I feel really dumb. It's like, how do you iterate over a list and then also insert stuff into the list while you're doing it, but also doing it lazily? That is my problem. You know, here's what we could do. And this is just gross. I'm not gonna lie, it's super gross. We could just say up here, if new defs is not equal to nil, new defs equals append new defs, comma, def. I hate it. I hate it. It is horrible. You know, I think what would make this a lot less horrible is if we put this into its own little helper method. So I'm gonna do that later. I'm gonna make sure to do that before I commit this. All right. So if we've done this up front though, what we're also gonna have to do is copy everything in, except for the like definition. So we'll say, ooh, and I think we also wanna just give it capacity. And not, because that'll just make things easier. We'll do append, not anything trickier. So we'll say new defs equals append new defs, and then we're gonna give it everything up until the current one that we're looking at, except not including it. So we'll say n, ooh, and we also need our current index now. This is what I'm talking about. It's like Go just makes you do this crappy list manipulation stuff just for no reason. Just because it doesn't have primitives, just because it doesn't have generics, basically, I think. All right, so n.defs, we're gonna give everything up to the current one, like that, dot, dot, dot. All right. And then basically down here, all the way down here, when we were going to append our defs to the end of n.defs, we're going to instead append it to our new defs. New defs equals append new defs, defs. Wow, I'm saying defs a little bit too much. Okay. I think this probably will work. So then we say n.defs equals new defs. And then this is violating a lot of principles, but hey, what are you gonna do? Let's try again. So the hope here is that once we're done with this test run, this Z will actually come after all of the column definitions for like table. And then the column definitions for other table will come even after that, which is currently true, but I think it's just because of reasons, because of luckiness, not because of anything smart. Okay. Expected duplicate constraint name, duplicate name, but no error occurred. Okay, I think I just like broke everything probably. Duplicate. Yeah. Seems like I totally broke everything. That's cool. Guess I want this. So if it's not a like table def and we, oh, I see. If new defs is not equal to nil. if we found any like table defs, we went ahead, we actually modified the list of defs during iteration, so we reassign the resultant iteration resultant list back to n.defs. Okay, I think that will fix that bug. Let us find out though. Cool. All right, I think we did it. This now appears in the correct order. We expect that the column ordering is relative to the like specifiers. Relative depends on the order of the like specifiers. Maybe that's okay. All right. I think, oh yeah, so then the last thing that we wanted to do is just make sure that this hash sharded index business is compatible with the like thing, which should be relatively straightforward if we add a test case for it. So let's see, we'll say statement, okay, create table hash sharded. Oh, you know what? We could actually just reuse one of the ones up here because I think somebody else created one. We'll just make a new one. Like hash base. A int index a using hash with bucket count equals 4. So we made our table, now we're going to make our like table, and this will fail at the moment until we fix whatever bug this is. Create table like hash like hash base. Statement okay. Then we'll say, we'll grab one of these. Look at the result of this thing, see what it looks like hash. Okay, let us rerun these. See what happens. It's gonna throw an error. It might even explode. No, today it passed. Oh right, it's because we didn't include the indexes. Including indexes. This is the thing that we expect to fail. Right, index primary contains unknown column row ID. Okay, so I guess what's happening, what is happening here? And basically what's happening, well, I don't know, I'm a bit confused. Because I think okay, did we make already a test case for having no primary key? We did, that was this. Oh, but we didn't say including indexes. So I think we have a bug that we have to fix that doesn't even have to do with the sharded indexes yet. I think that'll fail because it doesn't have that row ID thing. Yeah, all right. So let's see, how do we deal with that? I guess what's happening here is that we're trying to explicitly create a primary index, but the point is that it's been an implicitly created thing. So what we have to do is just not make that index at all. I think that should be pretty straightforward. what we have to do is look at the index. And if it's the primary index, which is true with this, then we just have to detect whether this was an implicitly created primary index or not. And I think that this is done somewhere else. I think somebody did this with inside of alter primary key. Hidden. I think fundamentally what we do is we just check to see if the index has any hidden columns and it's primary and the thing is called row ID maybe. What happens today if you say create table row ID int with no, what does this do? It makes a new one. But how can we detect that this index was made automatically? That I don't really know. What fields does this primary index thing have? It's got column names, which themselves won't really be enough. It's got this unique flag, which we've already looked at. Created explicitly. No. Well, what is this? i.e. via create index statement. Who sets this guy? Was this added recently or a long time ago? I don't know if we can trust it. This was added recently. No longer require cascade for... See, what I'm worried about is that... Well, first of all, I just don't know if this even has anything to do with what we want. What we want is a little flag that tells us, did this thing get created automatically by the system, or did somebody ask for it? But there's a few problems that I'm worried about. One is that who even sets this in the first place, right? Happens in make index descriptor. But who calls this? Doesn't that, oh, this is just by create index. Okay, so this actually won't get turned on for indexes that are included in the create table statement? That seems unintentional. That seems really unintentional. It's just for this hint. This hint seems sketchy to me. Anyway, but the point is that we can't actually use this, unfortunately. So what can we use? Can we use it at all? I don't know. I think the key probably has to do with let's look at this hidden field and basically check to see if the column name starts with row ID. It's really gross. It's really quite gross, but I think it might be the best thing that we can do. Oh, there's something here. Is primary index default row ID? This is basically what we want. Is primary index default row ID returns whether or not the table's primary index is the default primary index on the hidden row ID column. That's exactly what we want. Brilliant. So here we say if is pk and table descriptor dot is primary index default row ID, then we just don't even bother adding this index at all. So we just continue. I think this will fix it. Let us find out. We can rerun the test now. I think this is going to be good. I think this is going to be good. It's going to make sure that when we include indexes from this table that doesn't have a primary key, we don't accidentally try to make an explicit primary key. That was the whole thing we were trying to avoid. And I think that it will hopefully be fine. But I'm not going to count my chickens. I learned that lesson earlier this stream. Don't count my chickens about tests passing. Okay, so I think this is actually progress because this is the test that we were expecting to have to debug in the first place. So this one is looking good. What we did is we added A and B. We included the indexes. A and B stayed. It automatically added this row ID hidden thing, and it gave a implicit primary key that you can't see because it's implicit. So that's good. And then the last problem, though, is that line 297, line 297, what is line 297? This guy is just unhappy. It's getting an error. It's saying that index like hash base CRDB internal blah 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 contains unknown column empty. That sort of seems like I just made a basic mistake and didn't size this thing right or something like that. So let's go try to take a look. What could be going wrong? Oh, and I think I actually know what it is already. I think basically what happened here is that when I'm making these defs, oh no, I don't know what's going on. What I thought was that I pre-sized an array and then I like hit continue and then I didn't fill out the ones after the things that I pre-sized or something like that, but I don't actually think that's what happened. Okay, so what's happening is that we are looking at an index. So we're looking at the index that's automatically created, one of the indexes that's automatically created by this using hash thing. Well, I think there should only be one index that's created with this, right? I think it's just an automatic composite index. I should be skipping it, but I think, let's read that error message again. The error message says, index blah contains unknown column, other blah. Let's look at this, unknown column, or contains unknown column, other blah. This comes from somewhere deep inside of this. Wait. Index blah contains unknown column, other blah. So this happens when we're looking through the index's column names and we see something. Okay, so, and we are in fact editing the column name of an index somewhere, right? We were doing that. Index def. Ah, it is what I expected. Okay, so basically we're pre-sizing some array and we didn't fill it out. So instead what we'll do, instead of pre-sizing it, we'll start it at 0 and we'll use append instead of editing things directly. That hopefully will fix it. Index def dot columns equals append index def dot columns comma lm. This would be a nice little refactoring for the Goland people because I feel like I'm doing this all the time. Convert indexed range loops into append range loops or something. Index def dot storing equals append index def dot storing comma tree dot name. And of course I don't need this I variable anymore. All right, let us see. Will we have passed the gauntlet? I think this is good. I think this is good. I think we did it. Query TT. Let's look at what the original one looks like to make sure that we didn't inject some sort of horrible looking thing that was supposed to be hidden. But honestly, I think this is probably right. I think this is probably right. Yeah, that's great. Happy for me. All right. So what else is, let's see, anything else that we might not have tested for this like thing? One thing that we didn't do in the first place was add a like attribute for comments, but I don't really want to do that right now because it's a bit different paradigm-wise. Maybe I'll do that later, but I don't really feel like doing it right now. I think right now it just returns an error. And we could actually, that's a good thing to check. We could check that these like things are returning errors when we expect them to. So create table error like hash base including comments. I think this is going to return some sort of error. And then the other one that we didn't do is like storage or something. Yeah, so we have unimplemented statistics, storage, and comments. Statistics. Keep them alphabetized. This is gonna say error unimplemented. No, it just says syntax error. Oh, it's because I misspelled it. Stat sticks. Not the dream. Not the dream. Cool. Okay. So this is all good. It's groovy. It's groovy. Put a comment here. Add test the create table like functionality. Whoa. This looks weird. What is this? That seems really messed up. Identifier-ity? Seems like something got a little bit screwed up. I wonder, I mean, this is all generated too, so I wonder if there's some... It's pretty confusing, to be honest, because I didn't even edit anything to do with identity, did I? Oh, I did. I added a new token. Oh, yeah. Huh. I think that doesn't matter. It probably does matter. What could this possibly... What the heck could this be about? I guess like probably somebody's literally searching for ident in this package directory, and somebody's like regexing it or something. I don't know. I don't know. It doesn't make me very happy though. Let's see if this is already happening for other things in this file. Docs generate. I think what this thing is for, by the way, is that it actually generates these really cool docs in our docs page that tells you how the statements relate to each other and what the grammar is. Identity. Identifier-ity. Identity. Identifier. Oh yeah, this is already super broken. Because I think these are supposed to say ident. Oh, I see, but in this case it's okay because they're in quotes. But in this case, it's very not okay. Let's figure out what's causing this. Why not? It's just, shouldn't be too bad. Who makes these BNF files in the first place? DocGen grammar. DocGen. What is DocGen? This is new for me. DocGen. Seems cool. Extract. I bet it has something to do with ident in here somewhere, doesn't it? Let's go back to using grep, actually. That was a better strategy. RG ident. Opgen. Is there something in docgen? Yes. Ha ha ha. This is what I was afraid of. Okay, so diagrams.go. This is a little bit naive. It's replacing everything that says ident with identifier, but really I think what we want is replacing everything that says ident in quotes with identifier in quotes. What are the things that it does already? Identifier. I think everything else besides us has a quote. Yeah, let's just try that. We'll see if it works. Single quote ident. The thing is, I just don't know if the input already has the single quote. That's why I was hesitating. But we'll see. Make generate. This is, I mean, it's a really wide-ranging yak shave. I think. Very wide-ranging yak shave. So we're regenerating these docs, and we're going to see if these docs do in fact have the expected set of replacements for ident into identifier. Hopefully they do. That would be the dream. That would be the dream. It's interesting. I guess this is the first time that we've added something to the grammar that has the word ident in it that isn't just ident. Identity, identify. We don't have words like that in the grammar. Kind of makes sense. I don't know why you would. I'm a bit nervous that this is just not going to work though, because I think, my guess is that it's scraping the actual text of this grammar file, and at that point it doesn't have the quotes. Whatever this generate thing though is, it's super slow. Don't really know what it's doing. I know it's probably, oh, you know, I bet it already ran this. So I could actually already just check it. So let's background this and look. Okay, I think it worked. I think it worked. Identity is preserved. Great. Okay. So we are good to go. This thing, to be honest, I think we can just kill it. Okay. So where are we at? We are at the stage where I think we could probably make a commit. That is exciting. That is exciting. We added some parser tests already. Let's look at them again. Were they good enough? Including, this is what we added. Like B. Ooh, you know, this shouldn't even pass. I'm hoping that it won't pass. I don't think it will. I'm just gonna remove this because I know it won't pass right now. Let's run the test. Why don't we do that? We already ran the logic test. Let's run these parser tests again. Make test package SQL parser. And for some reason, a big amount of my build cache is dead. That's weird. Okay. Create table A like B, but found. Okay, so I have some bad stuff with this printing business. So I guess in the format method I implemented for these little like specifiers, I did something slightly wrong. That should be easy to fix. Where would that be? Like table something? Like table depth. So here's where I'm making them, excluding or including. I include the string. Oh, it's because I just put a space here, no matter what. But what I really should do is only put a space if I have any options at all. So I'll put an I here. I'll say if I is equal to 0. Wait, I think I actually want to put a space here no matter what, because these don't end with a space. Let's run this again. Okay, so what's wrong now? Expected this, but found this. Okay, that I guess we can just fix because we didn't. I guess int gets normalized to int 8 or something. So that's not really our fault per se. See you, CryptoSci. Thank you so much for tuning in. I appreciate it. Have a good day yourself. Okay, C int. Where did that go? There's a lot of things that say C int. Here they are. So we'll just make this C int 8. And then the other thing that was broken was that oh yeah, well, we're using something that we just didn't implement, so that's kind of goofy. We'll say including indexes. All right, and then for this other one, what's going on here? Expected success, but found adder near generated. Oh yeah, this was this other project that I started to do and didn't finish. So let's just remove that completely because we didn't do it. And then the last one, create table A like B. Expected error got nil. Oh, that's because we implemented something and somebody had added a test that it wasn't implemented. So we can delete that test. That's fun. That always feels good. Okay, expected like A. This again, I thought I fixed this. Thought I fixed this. Like A, like. Oh, what? How did I not? Oh, I just did it in one of them and not both. Very boring. Fixing test cases is not that fun. Okay, cool. Cool. So we finished our feature. And it's got another commit underneath it. But why don't we just add this commit on top and then send it as a PR. So we'll add all of our files. So we'll say, let's see, what did we do? We said SQL, add, create table like. Create table like allows the user to create a table based on the schema of a different table. Different combinations of including specifiers allow the user to customize which bits of the different table should be copied into the new table. So, and I guess we can say which specifiers we've made. This commit adds the specifiers. So we added indexes. Well, why don't we say including indexes adds all indexes from the source table to the new table. Make this a list. Including constraints adds all check constraints from the source. I'll actually just get rid of this extra verbiage because it's sort of pointless to keep repeating that. So we've got indexes, we've got constraints. What else did we add? I forget. Where is it? Including, that's a way to find it. So we added constraints, defaults, identity we skipped, so we'll defaults. Defaults adds all default expressions from the source. And we'll call these column expressions just to be a little bit more clear. Defaults, identity we skipped, generated. Generated adds all computed column expressions from the source. Indexes we did, statistics we skipped, storage we skipped, and then all includes all of the above specifiers. By default, create table like B will include all of the columns of B into A, including their nullability and nothing else. I think I should probably include something about column families in this because I didn't really, that's one sort of missing feature, which is right now the column family definitions don't get copied over from the old table into the new table. It's a little bit annoying to fix that. So I think for now I'll just include some documentation on that in this commit message. Column families are not preserved from the old table and will have to be recreated in the new table if the user wishes. I guess manually in the new table. All right. What else did we not do? We didn't do interleaves. Interleavings, I guess we can say column families, interleavings, partitioning, and foreign keys. I guess instead of are not, I'll say cannot be preserved, because no specifier will let you change the behavior of these. Is that basically what we want to do? Yeah. In addition, users can exclude specifiers using the excluding keyword. This is useful to include all and then remove things that aren't wanted. For example, create table A. I guess I'll also say like specifiers can also be mixed with ordinary create table specifiers. And I'll say, okay, so this is just an example for the commit message. A int primary key, B int index on B. So this will be our source, and then create table dest like A, C int index BC, like A, including indexes. Or I'll say including all, excluding constraints or something. I don't know. The dest table will get all of the indexes from A, but not its check constraints. And other things. Okay, so we'll say A and default 3. Yeah, not null. Default 3. Check. B is greater than 0. I mean, this is just, I don't know. It's like hard to make examples for this stuff because there's so many different combinations of things to exemplify. And defaults and so on from A, but not its check constraints. Because excluding constraints was specified after the like, after including all. I guess I should also mention the most recent including, excluding for a given specifier wins. All right, so then our release note, I mean, this commit message basically is a release note, but I'll just say release note, SQL change, add, create table, like specifiers. See commit message for more detail, examples, and documentation. Cool. Okay, so what now? Maybe we push this, we turn it into a PR. Pull this window up so you guys can see it. Can't automatically merge. Maybe I didn't rebase this. Okay, so we'll just probably have to quickly rebase. No problem. In the meantime, we can, well, let's just wait till this finishes actually. All right, so what is the matter? Somebody edited parse test in the same way that we did, I guess. Oh, wow. The whole, don't understand why it got so confused here. The only thing that I did is I removed a line. So why don't we just take exactly what they had? We'll just take exactly what they had and then just re-remove the thing that we wanted to delete. That'll be the easiest way to resolve this, I think. Now we just want to remove that unimplemented like thing since it's now implemented. And re-add this, rebase continue. Okay. Now we can re-push this thing. And over here, if you refresh, hopefully it will no longer think that I cannot merge it. And I should be able to make a little message. So we'll call this PR this, even though there's a couple of different commits. We'll just paste this big bad boy comment. If it's got spaces, that's annoying. Let's fix that up. Probably probably there's a way to do this without editing it by hand, but hey, I don't know what it is. grab this. Grab this, put it in here. Oh gosh, did I not copy it? Copy it here. Okay, so this is looking good. And then, to be honest, I also did another small change that I should probably include into the PR, which is this. I never know how to phrase a big PR that has 2 commits. Also includes this, which is just a small change realistically, but it is something that is nice to fix. And I'll just keep both release notes, I guess, because why not? Let's see, who should review this? I think I'll put Andrew, because he knows a little bit about these hash started indexes, so he can review that one commit. And then maybe Rohan. Maybe Rohan, if you're still on, you can look at this. That would be nice. All right. If you could take a look at the little fixes to all right. Well, I think this would be a good place to stop. I was gonna maybe do some partial index stuff, but it's already been like 2.5 hours on bike shedding for Create Table Like, which was actually pretty fun. I enjoyed it. And I think it's a little bit less painful to watch me do stuff like this than to do partial indexes, because that stuff is hard. So I think I'm gonna call it for now. So thanks everyone who's been watching. I appreciate you. Appreciate you tuning in. I'm gonna switch to my full face view. So yeah, thanks for watching. Probably gonna try to do this every week. I think I missed a couple of weeks in the past because just trying to get used to working from home all the time. But now that I've been doing that, I feel pretty good about streaming on Fridays again. So hopefully I'll keep doing that. Definitely let me know if you have ideas for things to learn about in CockroachDB. I'm happy to do them on stream or make a video. I've been making a couple videos, put them on YouTube. I made one on column families and made one on interleaved tables, and I think those have been pretty fun. So give those a watch if you're interested in those topics. And yeah, I think that's all I had. So until next time, enjoy. Thank you for tuning in. Make sure to follow if you haven't already done that. Thank you. All right.